Let's solve this problem step by step. We'll start with part A, proving that a function f from S to S is injective if surjective, where S is a finite non-empty set. Let's visualize this with a simple example. Consider a finite set S with three elements. We'll call them A, B, and C. Now let's understand what it means for f to be surjective. A function is surjective if every element in the codomain has at least one element mapping to it. Since S is finite and f is surjective, each element in the codomain must have exactly one element mapping to it. This is because if any element had more than one element mapping to it, some other element would have no elements mapping to it, contradicting surjectivity. Therefore, f must also be injective, as each element in the domain maps to a unique element in the codomain. This completes our proof for part A. Now let's move on to part B, where we need to disprove the statement that open parenthesis x plus y close parenthesis to the power of n equals x to the power of n plus y to the power of n for all natural numbers n and integers x and y. Let's find a counterexample. The simplest case would be to try n equals 2 and x equals 1 and y equals 1. Let's calculate the left side first. 1 plus 1 superscript 2 equals 2 superscript 2, which equals 4. Now, the right side. 1 superscript 2 plus 1 superscript 2 equals 1 plus 1, which equals 2. Since 4 is not equal to 2, we have found our counterexample. Therefore, we have successfully disproven the statement by providing a valid counterexample.